Thank you, Paul. And thank you all for coming to this talk. So, over the last decade, me and Judy Macera have been working on Ichthyosaurus, and we've come across various different unusual features in the narial region that we have interpreted as possibly salt glands. And in fact, we said that in a recent paper that we submitted. We said, oh, we think we have the presence of salt glands in Ichthyosaurs, and inevitably it was shot down very quickly by the reviewer who said, where is your evidence? So this is the evidence, hopefully. So first and foremost, function, the function of salt glands. So when marine predators, big marine predators, when they eat, they inevitably ingest some seawater, and they obviously have to get rid of the seawater. Invertebrate prey is isotonic with seawater, essentially meaning it has roughly the same composition, the same saltwater content. So again, animals that are feeding on invertebrate prey will also be ingesting additional salt. So for these two reasons, thus, predators need a way to remove the excess salt, hence salt glands. Now, salt glands in ichthyosaurs is a good hypothesis, because you'd imagine that because they're marine reptiles, they're in the marine environment, they need to get rid of salt somehow. So the occurrence is found in the following extant tetrapods, only in turtles, snakes, crocodiles, lizards, and birds. That's it in extant tetrapods. Now, I should point out that because obviously they live in the marine realms as well, marine mammals, they do not have a salt gland. They have extra, very, very strong, good kidneys, and all of this salt comes out in their urine, just to leave you with that nice fact. So the occurrence, it changes the position of salt glands, varies quite a bit from orbital, oral, and nasal salt glands. So we have orbital salt glands are only found in turtles. The oral salt glands are found in snakes and crocodiles. And finally, nasal salt glands in lizards and birds. And this is extant taxa only. Now, in extinct marine reptiles, the oldest definite occurrence is from the Permian, and that's in Mesosaurids, from a study from Pinheiro et al., 2010. Next in the Triassic, from Nothosaurids. Then Mitrirhynchid crocodiles. From the Jurassic, there's various studies being undertaken on them. And then finally, also one single plesiosaur from the Cretaceous. And that's about it, apart from a couple in Ichthyosaurs. So the only definite, really good, compelling evidence that we have for salt glands in Ichthyosaurs is from a study by Bill Wall, who happens to be one of our co-authors, so I would like to think that it is a good study, and it's pretty definite, but it convinced me anyway. And that's in Ophthalmosaurus natans from the late Jurassic of Wyoming. There has been a suggestion in Mixosaurids from the middle Triassic, and that was by McGowan and Matani, 2003, who suggested that possibly Mixosaurids had a salt gland. And then finally, this presentation. So Ichthyosaurus and other taxa from the early Jurassic. Now, hopefully, in the next few slides, I'm going to convince you that it is the case that we do have salt glands in Ichthyosaurus and other early Jurassic taxa. Okay, so structures in Ichthyosaurus. The very first one that we noted was this weird projection that demarcates a circular region at the back of the nares. So here is, comes up, here's a holotype of Ichthyosaurus larkini. You can see the big orbit. Orbit set is there for your information. The external nares is this long thing here. Now, what I'm pointing at, this little arrow, that is a tiny little projection that we found in a bunch of specimens. So that's on the bone, which is called the lacrimal, on the anterior process, and that projects into the nares, and you can see that then sort of demarcates this circular region at the back of the nares. Now, it's a really long nares, this. And we began to find that on a bunch of different specimens. So here is another specimen, which is not identified to species, but it definitely belongs to the same genus, belongs to Ichthyosaurus. And again, you have the same thing. So you have the tiny little triangular process on the anterior process of the lacrimal, and again demarcates that anterior, that circular region at the back of the external nares. Same on this specimen, again, another example of the genus, and it's really well, you can really see that very well on this, the triangular process, and again, that circular region at the back. Now, another feature is a sort of a ring of bone in the posterior nares. Now, again, this is only present on a handful of specimens, but one of the best is in the holotype of Ichthyosaurus somersetensis. So again, you can see where the orbit is, and you see where the external nares is. And what we're looking at here is this sort of ring of bone. Now, you could probably say that, well, this skull's a little bit crushed. In fact, I should point out that in the external nares, that's a tooth. So that's from the other side. So there's something funny going on here. So maybe you could say, fair enough, okay, in one specimen, this ring of bone is just a piece of bone pushed from the underside. Maybe it's from the palate or something like that. But we can't figure out what that is. There's no bone in the palate or anything that matches that. So that's unusual. Plus, we have a couple more specimens showing the same sort of thing. So here's another specimen of Ichthyosaurus somersetensis, also with the circular region, and also has a process on the anterior procerolacrum, that little triangular thing. And another specimen. So again, right at the back of the external nares is this circular ring of bone. So obviously in one specimen you could imagine, yeah, okay, it could be a preservational thing, but in a bunch of specimens, and we've got a couple more as well, again, it's something quite unusual going on here. So what about this as well? So the posterior nares can sometimes appear more resistant to crushing than the anterior section. So if we look at a specimen in dorsal view, so looking top down, again, point out where the orbit is, that's the external nares there. Now the intriguing thing here is that's the anterior portion of the external nares. This is the posterior. Noticeably, it's much larger. Now again, you could possibly say that's due to crushing, but we found that in several specimens. So there's certainly something going on at the posterior end of the external nares, and that's another intriguing factor. Also, the lacrimal forms a higher edge to the nares posteriorly, and by that, if we take a look there, you can see where, again, you've got this sort of circular region in here, but it protrudes outwards, it sort of points outwards. Now, the best way of looking at that is in a three-dimensional skull. So here's a specimen of Ophthalmosaurus isienicus, previously on display at the Natural History Museum in London, but this also occurs in many other ichthyosaurs, including Ophthalmosaurus natans, which is the specimen that Bill Wall described in the 2012 paper. And the point here is that what you're looking at where the arrows are is you can see where if we look straight down this ichthyosaur, staring it in the face, staring it in the eyes, you can see that it has this really narrow skull, really narrow snout, and then all of a sudden it sort of protrudes outwards right at the point at the back of the external nares. That's intriguing. And it's an interesting position because it asks the question, what's going on? Well, potentially, this might indicate that nasal salt glands, or at least a salt gland duct, in the posterior nares, just anterior to where water would flow along the skull and where it would spread out, which is interesting because the higher posterior edge of the nares could create eddies, so circular motions in the water that could help concentrated solutions could efficiently be carried away during swimming. So it's a good possibility that that could be a great position for a salt gland in ichthyosaurs. Of course, there is another possibility that we've considered, much more speculative, but it could even be something like this. I don't know if anybody has seen what marine iguanas do. There's a very short clip I'm going to play. Ignore the one at the front that kind of tries to steal the show. Focus your attention on the one at the back. Play. Oh, no. Damn. Oh, well. Never mind. It's only very, very short. So essentially this one the one at the front starts to sort of make some movement, but the one at the back turns its head and it blows out excess salt that it takes in when it's going and swinging around in the marine realms. So it's not impossible that ichthyosaurs may have done something similar, come up to the surface and blow out the excess salt. Possible. Of course, that's now a nice image for you because you're going into lunch and you're going to be eating food, but never mind. So aside from Ichthyosaurus, we have found this similar structures in other taxa. So this is Temnodontosaurus trigonodon, a specimen from the Posidonia Shale in Germany. And with this one, you have, although it's not quite as distinct, you've got this thing again, you've got the big lacrimal here, going all the way around the back of the external nares here, and you've got this sort of protrusion. In another specimen of the same species, you've got, again, something quite unusual going on here in the external nares. Got that weird protrusion. And that's, again, intriguing. It's slightly different to what we see in Ichthyosaurus, but clearly there's something going on here. Now, another specimen, this is Halpheopteryx typicus. If we look again at the lacrimal, you have again a weird, the maxilla, you have a weird triangular process on the, on the lacrimal, which also demarcates sort of a circular region at the back. Although this is disarticulated, you can clearly see something is going on here, and you've got this circular, semicircular pattern there. So similar structures also in other taxa. This is where it gets kind of unusual. So this is a thing called Ichthyosaurus from the early Cretaceous of Colombia. Now this has a longer projection, but this is on the nasal rather than the lacrimal. So this is an intriguing thing. It was only published just the other year by Maxwell et al. And what we're focusing on here is the same thing. So you've got this time this weird process coming down from the nasal, but intriguingly, you also have a very tiny bit on the lacrimal, that little triangular process, which we've seen in Ichthyosaurus. So again, that's unusual. And at this point, it's almost separating the external nares into two distinct pieces, which is intriguing, again, because a similar descending process has been reported in other ophthalmosaurids, including one figured by Gasparini, 1988. Again, we've got almost where this descending process on the nasal is contacting the maxilla, almost. And the same again in another paper recently published by Fisher et al. This is for the ophthalmosaurids Sveltonectes. We've got this weird fang-like process coming all the way down, almost touching the maxilla. Now, in those specimens, it's been interpreted that it's a double nostril. Now, the thing is, I'm not quite sure if any animals have a double nostril that would indicate 4 openings to the nostril. I'm not quite sure what that would be used for. And so that's intriguing. But taking it to the next level, in Symposium, this was truly partitioned where you had the nasal and the maxilla come together. So there are 2 distinct openings in the external nares. So you had essentially an anterior and a posterior external nares. Again, I'm not quite sure what a double nostril would work out here for. And so that's our inference that potentially, could that be a fully partitioned nostril opening? So you have one is actually for the nostril, the other one is for a salt gland. Right, cheers. And then the final thing really with this is, what about a septomaxilla? So the septomaxilla is a very tiny, delicate bone that is sometimes found in the narial region. In Ichthyosaurs, it was first suggested by Solas, 1916. He was cutting up an ichthyosaur skull, and he found what he thought to be a septomaxilla, but various other authors came along following his inference and suggested these things may also be septomaxilla. But the problem is, absolutely every single suggestion is based on very, very fragmentary material, and it's just on an isolated bit of bone in the external nares. So there's no real convincing evidence of any of them, and it's pretty dubious. So what is being called a septomaxilla could be a structure related to a salt gland. So in conclusion, structures occur at the posterior end of the external nares in at least some Ichthyosaurus specimens. The problem with that is why is it just some specimens? Of course, it could be a preservational issue, and we've begun to discuss that within the paper that we're currently writing, that potentially it could be a preservational thing where obviously crushing could affect these certain features. Also, the way in which you can look at some of these specimens, because of course, many of the things that we're looking at are laterally compressed, so they're kind of like pancakes, so you only have a certain view. So that could be one issue. But of course, these things also occur in many other taxa. And finally, most likely explanation in our interpretation is that these are nasal salt gland. If not, then what is it? And I'll be genuinely intrigued to see what other explanation you can come up with. So finally, a few acknowledgements, and thank you all for listening. And please ask me any cool questions about this, because I really want to try and figure out what this thing is. Thank you.